So in the first part of the first question, we are asked to use interpolation to estimate the median time spent on maths homework. So first things first, we need the interpolation formula. Obviously, they work in reverse alphabetical order. That's one way of remembering them. We found bacon, or we found more bacon, if that helps you remember it. So that's our interpolation formula. We know that there are 30 students. So 30 divided by 2, that's the 15th piece of information. Well, in fact, we know it's the 15.5, but let's go for the 15th. And that falls into the 200 to 219 category, because before that, that's 8 bits of data. Adding on the 9 then gives us 17, and of course the 15th and a half lies in that group. Good, so that's our nth. We know what our nth is now. So what is our nth we know is 15. Our group width, that is the width of that group, well that's 199.5 to 219.5, so that's 10. The group frequency is 9, and the group bottom, that's the true group bottom, is 199.5. So putting all that information into the interpolation formula then, the median must be, not the bracket first, there we go, must be the group width, which is 10, lots of 15 minus, right, total data. Total data before, so it's anything before our group, well it's 3 plus 5, so that's 8, divided by 9, and add our 199.5. And that should give us 215 to 3 significant figures. And that's it. So part B asks us to estimate the mean and standard deviation of the data to 3 significant figures. The main place that people lost marks on this was just an inaccuracy, so be really, really careful when you do questions like this, just to check them. So we're going to do, for the mean, we're going to do midpoint, and then times the frequency, obviously dividing by the total frequency, and that should give us the mean. So midpoint for the first group is 169.5, it's 189.5 in the next one, and so on and so forth. You can get the gist. And multiplying that by the frequency, so obviously times 3 times 5, etc, etc, etc. That should have given you 6,461, and we're dividing by 30, which is, calculator at the ready, 6461 divided by 30 is 215.3667, which is 215 to 3 significant figures. Now my calculator isn't going to handle the standard deviation, but I'll just talk through what it is and give you the answer that you should have got. So standard deviation we know is the square root of variance, and so obviously we're going to have an answer for variance, we need to square root it. Variance is the sum of the midpoint squared times by frequency divided by the total frequency, and then subtracting the mean squared. So what we'd need to do is to square all the midpoints, which we found for our mean anyway, multiply those by the frequency, add them up, divided by the total frequency, minus the mean squared. A lot of people missed the squared bit off the mean. And I believe, if memory serves me right, you should have ended up with 26.1 to 3 significant figures. Any problems with that, give me a shout. And then part 3 says, by comparing the mean and the median, comment on the skew of the data. You have 2 options. Basically, to 3 significant figures, the mean and the median are equal to each other. They were both 215. So you could say there's no skew. You could take the fact that the median was 215.1, I think, and the mean to be 215.3, so past the 3 significant figures point, and say there's a slight positive skew. Up to you. I think I would be tempted, since they've asked for answers to 3 significant figures, to look straight at that, but both options were acceptable. If, however, you had the mean greater than the median, don't forget that's a positive skew, and likewise if the mean had been smaller than the median, that would have been negative. Question 2 asked for it's talking about histograms. A histogram is drawn. We don't have to draw it necessarily, but we're saying it is drawn to display the following data. Given that the bar representing the weight 60 to 69 has a height of 5.2, calculate the height in centimetres of the bar representing 90 to 94. Okay, so 60 to 69. 60 to 69, that's a class width of 10 and a frequency of 5. So we know frequency density is calculated by doing the frequency, which would be the area, divided by the class width, which is 5 over 10, which is 0.5. And we know that that 0.5 as a frequency density is actually represented by a height of 5.2 centimetres. So we could work out a scale factor or ratio there by saying what does it take to get from 0.5 to 5.2. And so if we do 5.2 divided by 0.5, we should get that scale factor. That's multiplying by 10.4. In the 90 to 94 bar, where are we, 90 to 94, the class width is 5 and the frequency is 2. So our frequency density for this bar would be 2 divided by 5, which is 0.4. So we've now got a frequency density of 0.4, but we know that that won't be a height of 0.4 centimetres. We know we've got to multiply by a scale factor. So 0.4 times by our scale factor times by 10.04 is 4.16 centimetres. And that's the height of our bar. Okay, so in this third and final question of our stats paper, we are given a nice stem and leaf diagram. Raw data, so we're not handling groups. We know what the value of each piece of our data is, so in theory it should make it quite simple. So in part 1, we're asked to find the median and the quartiles of this data. We've got 30 pieces, so let's do 30 divided by 2, that's 15. Now, of course, we know we don't really want the 15th. If you had 30 pieces of data and you crossed off a bit from each end, you'd end up with 2 in the middle. So that's precisely what we need to do. We need to do the 15th piece, add the 16th piece, and divide by 2. So the 15th piece is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. I might need to count that again. This is another problem with stats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. Yep, and the second one is 18. So that should give me 17.5. The lower quartile would be the quarter of 30, which is 7.5. Since it's a decimal, we round up to the 8th piece of information, which is 1, 2, 4, 5, 6, 7, 8. 7. And the upper quartile is the 3/4 of the data, which would be 20... I can tell my brain's not working tonight. 22.5. Alright, 22nd.5. It might be worth counting backwards from this one, to be honest. We're going for the 23rd piece of information, because again, we've got a decimal. So that's the 30th, 29th, 28th, 27th, 26th, 25th, 24th, 23rd. 23rd is 30. Not too difficult for 4 marks. Part B asks us to work out if there are any outliers, but luckily it gives us the rule it wants us to follow to work out outliers, which is to take Q1, which we knew was 7 from last time, and subtract 1.5 lots of Q3 minus Q1, which is of course the interquartile range. Well, we knew Q3 was 30, and we're not going to need it, but let's just pop it down. Q2, of course, is 17.5. Okay, So our lower outliers are 7 minus 1.5 lots of the interquartile range, which would be 23. So popping that in your calculator, it's going to be a negative number, so we know we're not going to have any outliers, but we may as well do it. And you certainly need to in your exam. So 7 minus 34.5 is minus 27.5. So no lower outliers. You actually need to be quite clear about that in your exam as well. What about the upper outlier then? Or liars, obviously. That's going to be Q3, which is 30, add 1.5 times the interquartile range, which is 23. So 1.5 times 23 is 34.5. I'm going to add 30 to that, which is 64.5. Right, is there any data above 64.5? There is. There is one outlier at 70. Last part of the question, worth 4 marks to use, to draw a box plot. We don't obviously have graph paper, you can certainly draw it on line paper, to represent this data. Okay, so we have Q1 being, let's try writing that properly. We have Q1 as 7, Q2 is 17.5, Q3 is 30, and we have one outlier at 70. Okay, so first things first, you definitely need, in a question like this, is an equal scale. Now, I'm not going to be able to draw a perfectly equal scale, but hopefully you'll all remember to bring a ruler into the exam, so it shouldn't be too difficult for you. It should be 50, not 70, 60, 70. Next thing we need to do is obviously mark on our data correctly. So our lowest piece of data that isn't an outlier, and of course we don't have any, so that's good, is 1. So it's just past the 0 there. That's our bottom whisker at 1. Our top whisker is the next piece of data that is, well, the highest piece of data that isn't an outlier. Now we know that 70 is an outlier, so the next highest piece of data is 63, so that will be our top whisker here, 63. We've got an outlier at 70, that's represented by a cross, so we can put that on as well. Now our lower quartile forms the bottom of the box, which is 7, so that's about here. Our upper quartile forms the top of the box at 30, so that's there. And our median forms the middle line, which is 17.5, and that's in there. And then all we need to do is draw our box together and join up our whiskers.